Hello students, welcome back. We will continue with the chapter Algebraic Expressions and Identities. Here today we will be learning about different types of identities. Alright. In the previous classes we have learned about multiplication of binomials and binomials, monomials and monomials and so on. Now we will be learning about certain type of identities, or you can even call them as formulae. Alright. So the first identity or the formula that we will learn today is a plus b the whole square. Now this a plus b the whole square is equal to a square plus b square plus 2ab. This is the first identity that you have to memorize or by heart or understand it. Alright? So this is your first identity. This a plus b the whole square is simply a plus b into a plus b. That means I'm multiplying a plus b 2 times. Right? When you multiply 2 times, you get square. Right? So this is a binomial into binomial. If you want to understand how we are reaching this part, you simply have to multiply these two binomial. Okay? So this is the first identity. Please keep in mind that you have to memorize this and understand how it is coming about. So as I have shown you, multiply the two binomials, you will get this expression. So this is the first formula. The second formula is a minus b the whole square. Alright? A minus b the whole square is almost the same as a plus b the whole square. So we will write a square plus b square. The only change that will come is instead of this plus, it will become a minus 2ab. Now this is the second identity or formula. Similar to the first one, here a minus b the whole square means a minus b into a minus b. So when you multiply these two, you get a minus b the whole square. Alright? The third identity, a plus b into a minus b. If you solve this, you will get a square minus b square. So these are the three standard identities. Okay? So you have to memorize them. Please keep it, you have to have it in your fingertips so that you'll be able to solve the problems that we are going to solve in the next question. And there's one more formula that you have to memorize, that is x plus a into x plus b. Now this formula may not be applicable in many cases, but sometimes situation will arise where you will have to use this particular formula. Alright? So this formula, simply you write it as x square plus a plus b into x plus ab. So this is your final identity that we'll be learning about. These four identities are very important, especially the first three. Memorize it, by heart it by any means, because this you're going to be using it in the next higher classes. Alright? So to understand them better, let's perform some exercises in exercise number 9.5. Please turn to page number 151 in your textbook. Exercise 9.5. Let's start with the first question. Use a suitable identity to get each of the following products. Now, they have given us, in the first question, they have given us like this. X plus 3 into x plus 3. Alright? They have simply given us two expressions. They want us to use identities. Alright? So, the first question we can write like this. X plus 3 is being multiplied 2 times. That means x plus 3 to the power 2. Right? And x plus 3 to the power 2 is in the form of a plus b to the power 2. Isn't it? Your x will be your a, your 3 will be your b. Okay? Now we know this expression, a to the power 2 plus b to the power 2 plus 2ab. Now in place of a, b, we will write x. In place of a, we will write x. In place of b, we will write 3. So we can write like this. In place of a, we will write x. So a square will become x square plus b square will become 3 square plus 2 will remain as it is into a will become x, b will become 3. After that, it is simple multiplication. X square will not change, it will be as it is, plus 3 square will become 9, plus these 3 terms you can multiply directly. Multiply the numbers. 2 into 3 is 6. X will remain as it is. So this will be your final answer. Here we used this identity. Okay? Similarly, let's look at question number 3. It is given 2a minus 7 into 2a minus 7. So, see, you can see that both of them are same. They are being multiplied 2 times. So, we can write this as 2a minus 7 to the power 2. Okay? 2a minus 7 whole to the power 2. Now, we have already learned about this expression, a minus b the whole square is equal to a square plus b square minus 2ab. Okay, same as the first question. In place of a, now I will write 2a. In place of b, I will write 7. Right? So, in place of a, 2a the whole square plus, in place of b, 7. That means 7 square minus 2 into, in place of a, 2a, in place of b, 7. Right? So here, 2a the whole square means 2 will be multiplied 2 times, a will be multiplied 2 times. So 2 into 2 is 4, a into a is a square, plus 7 multiplied 2 times, you get 49, minus, now you have to multiply these 3. So multiply the numbers first. 2 into 2 is 4. 4 into 7 is 28. And a. So this is your final answer. Alright? So this, here also we have used the second expression, this one, right? So similarly, let's look at the next question. Let's look at question number 6. Here we see a to the power 2 plus b to the power 2, bracket close, minus a to the power 2 plus b to the power 2. Now, so far we have not seen any identity in this manner. All right, we have not seen any identity, but here we have to make some arrangements. Okay, we're going to make some few changes. So the changes will be like this: a square plus b square is given like this, right? But now we're going to change the position of these terms. B square will come first plus a square. For example, 2 plus 3 is equal to 5, right? So if I change the position again, 3 plus 2, you are still getting 5. So whether you change the position or not, it's all the same, isn't it? So it's similar to this. So you're writing b square plus a square into, now again in the second expression, b will come in front. B square, now minus a square will be in the second place. Okay, now here, if you look at this expression, this b square will be your a, okay, and your a square will be your b. Similarly, you will write it like this, ab. Now there is an expression that we have learned, identity, a plus b into a minus b is equal to a square minus b square, right? You will apply this identity here. So in place of your a, you will write b square. In place of your b, you will write a square. So this will be written as, sorry, in place of a, you will write b square. But please do not get confused. Your a is b square. So I'm writing a here. Now there's one more square. So I'm writing the whole square, okay? B to the power 2, the whole square, all right? Minus, for b, I will write a square. And there's one more square, so I will put the square outside again. So it will look like this: b to the power 2, the whole square, minus a to the power 2, the whole square. So when you simplify them, these two powers will be multiplied. 2 into 2 will be 4. These two multiply 4. So your final answer is b to the power 4 minus a to the power 4, right? So this is the third identity that we have seen, right? So let's look at some more examples. When you go to question number 2, they're asking us to use the identity x plus a, x plus b is equal to x square plus a plus b into x plus ab. The fourth identity. They want us to use this identity and solve the question. So the first question is x plus 3 into x plus 7. So we're going to use this identity that they have provided us with. So here, if you compare these two expressions, your x is same, right? But your a will become 3, your b will become 7, okay? So in place of a, I will put 3, in place of b, I will put 7. So let's see, x is same, so I'm going to write x square plus, now a plus b, in the identity it is a plus b, but here we're going to replace a by 3 plus b will become 7 into x plus ab. AB simply means 3 into 7. When I write AB, it means A into B, okay? If I write XY, it means X into Y, all right? So AB will be 3 into 7. Now simply solve it. X square plus 3 plus 7 is 10. And there's X here plus 3 into 7 is 21. So in this question, question number 2, this is how you will solve. It's all the same, no difference, very similar to all the questions, only the numbers will be changed. But there is one question where we will have to focus a little bit. It's given 4x minus 5 into 4x minus 1. Now this question does not fit with this. It is x plus a. There's a plus here, right? But we have a minus here. So we have to make some changes here. The first change that we're going to do is like this. 4x, this minus I will change to plus, okay? And this minus I will take with 5. That means your 5 will become minus 5. See, plus into minus will give you minus. It will come the same thing again, okay? Similarly, 4x plus this minus will go with 1 and you will see the expression in this manner, okay? So now you have x plus a, all right, into x plus b. So you can write like this, xa, xb, okay? So when you put it in this formula, you're going to write in place of a, you're going to write minus 5. In place of b, you're going to write minus 1. All right. So let's put it in the formula. X squared plus, in place of a, minus 5. In place of b, minus 1 into your x. Your x is nothing but 4x plus ab, multiply these two, minus 5 into minus 1. All right, so this is simple calculation now. This minus 5 will remain as it is, plus into minus will be minus, so minus 1, 4x plus. Minus into minus is plus, so you will keep it as it is. 5 into 1 is 5. So finally, x squared plus minus 5 minus 1. Both are minus, so you have to add them, right? So you're going to add it, so 5 plus 1 is 6. But both are minus, so you will write a minus sign in this manner. And 4x plus 5. So in the next step, x squared, now there's a plus here and there's a minus here. So I'm going to multiply these two. Plus into minus is minus, okay? And 6 and 4, you have to multiply them. So you get 6 into 4 is 24. This x will come as it is. And finally, plus 5. So this is your final answer. Similarly, for all the rest of the questions, due to time constraint, I have not been able to solve everything, but more or less they are all the same. You simply have to memorize the identities properly. And before we wind up, I just want to give some clues on how to solve some questions. I'll quickly show you a few steps. Question number 6, 1. Using identities, evaluate. They have given us 71 square. Now this, there's no identity which will help you to solve this, right? But to make it possible to use identities, we have to make some changes. So what I'm going to do here is, I'm going to change this to 70 plus 1. 70 plus 1 is 71, the whole square. So this has come in the form of a plus b, the whole square. All right. Similarly, for other questions, you have to make it in this manner. All right. And if you continue by applying the formula, you will get the answer. It's quite easy. If you look at question number 6, 297 into 303. So here also you're going to make some changes here. 300 minus 3 will give you 297 into this 303 can be written as 300 plus 3. So this is x minus a, x plus a. Or, sorry, we can simply write it as a minus b or a plus b using these formulas. So this is how you will arrange these expressions, and by arranging these expressions you'll be able to apply certain identities in this manner. So with this we will have come to the end of this lesson. I hope you will keep practicing, and please without practice this chapter is going to be tough for you. The more you practice, the more easier it gets. So all the best and study hard. Thank you.